talked about binary codes. Binary codes are codes for only numbers. If you have a number 0 or 1 or 2 or 3 like this, if you want to transmit the number from one place to another place, just numbers, for that we have binary codes. If you want to transmit some text also, which is containing numbers and also characters and the special characters like exclamation mark, question mark, comma, full stop, all these things. If you want to transmit text which is including the numbers, special characters, and commas, all these things, commas, full stops, all these things, we need a separate code for that. We cannot do it by using BCD codes or codes that we have developed in the previous topics. So here we have developed codes called alphanumeric codes. Now we will see what are the alphanumeric codes which are used widely, which are standard codes. In order to communicate, we need not only numbers but also letters and other symbols. In the strict sense, alphanumeric codes are codes that represent numbers and alphabetic characters such as symbols and various instructions necessary for conveying information. So if you consider, at a minimum, alphanumeric codes must represent 10 decimal digits. Why 10 decimal digits? 0 to 9, and 26 letters of the alphabet. 26 letters we have. You can use either uppercase or lowercase. 26 letters of the alphabet for a total of 36 items. So we need alphanumeric code which contains at least 36 items. What are these 36 items? Out of 36, 10 are decimal digits and 26 are characters, ABCs. So that's how we get this 36 items. This requires, in order to represent 36 decimal digits, 36 decimal, how many binary numbers are needed? If you use 5 binary numbers, with 5 binary numbers you can have 32 combinations, only 32 combinations, but we need 36 items. So you need 6 digits. You need 6 digits. So 2 power 6 is 64. There are 64 total combinations for 66 bits. So there are 28 unused code combinations. If you use 6 bits for alphanumeric codes, you will get 64 total combinations, out of which we need only 36. So these 28 combinations, they become unused, and that is not the case. We use these 28 unused combinations for other purposes. You may include lowercase here if you have included uppercase already in the 36 items, like that. So in that 28, what we do is, obviously in many applications, symbols other than just numbers and letters are necessary to communicate completely. So we need spaces. So we also need spaces. Periods means dots, colons, semicolons, question marks, and so on. Without this, it is not a proper text. If you don't consider spaces, periods, colons, semicolons, and so on, the text will not be a good text. Without this, you cannot understand the text correctly. So we need all these things along with the numbers and digits. So what we do is, we also need instructions to tell the receiving system what to do with the information. So we need some control characters also. Means this, which is the first letter, or which is the start. How do you tell the receiver that this is the starting of the paragraph, this is the ending of the paragraph, and so on, this is the heading, and so on? How do you tell that? How do you tell the receiver all these things? So we need some control characters also that may not be displayed, but they are useful in order to present the text properly at the receiving end. So with the codes that are 6 bits long, you can handle decimal numbers, the alphabet, and 28 other symbols. So finally we have come up with some standard called ASCII code. ASCII code. In this ASCII code, we have one standard called ASCII code. In this ASCII code, let's understand this ASCII code. So one widely used example of alphanumeric code is ASCII code. So ASCII is the abbreviation of American Standard Code for Information Interchange. This ASCII stands for American Standard Code for Information Interchange, and it is universally accepted alphanumeric code and used in most computers and other electronic equipment. So whatever the electronic equipment we are using, and the information is represented or it is transmitted in by using which code? ASCII code. Now let's see what is this ASCII code and how many ASCII symbols are there and so on. So consider this diagram. This is called ASCII, simple ASCII table, ASCII chart. Here we have decimal representation, hexadecimal, its equivalent hexadecimal representation, and this is the character. Totally, if you count from 0 to this column has the ASCII numbers from 0 to 31, in hexadecimal 0 to 1F, and in the second column we have 32 onwards, 32 to 63, and its equivalent is also shown here, and here 64 to 95, and the last ASCII code is that box, and whose decimal equivalent is 127. Its hexadecimal is 7F. So this many, totally we have 0 to 127. Totally we have 128 different ASCII characters, which includes, see, the first column 0 to 30, 0 to 31. Totally we have 32. These are the characters which cannot be printed or which cannot be displayed. These are the control characters. This column contains control characters, and in the ASCII table where they are allocated from 0 to 30, 0 to 31, 0 to 31. So first 32 characters are control characters which are not normally displayed, nor they can be printed. So from 32 onwards, and from 32 onwards we have characters which can be seen, which can be printed. Let's see, 32 in decimal 32, its equivalent hexadecimal is 20. What is the ASCII character? What is the ASCII character for the decimal 32? Space. What is the ASCII character for the decimal 33? Exclamation mark. And its equivalent is 21. Hexadecimal equivalent is 21. Now in the same way, we have characters, uppercase letters from decimal 65 onwards, 65 to 90, and its hexadecimal equivalent is 5A here, and it starts with 41 and ends at 5A. And we have lowercase also. Lowercase starts at 97, whose hexadecimal is 61, and it ends at 122, whose let's continue with the alphanumeric codes. What are they for? If you want to transmit the text which is having characters, numbers, these things, you need not only numbers, you need characters also, right? And let's say characters means ABCs. How do you send ABCs? In a digital system, you cannot transmit A from transmitter to receiver. You should transmit A in the form of ones and zeros. For that, we have a code called ASCII code, which stands for American Standard. What is this ASCII stands for? I forgot it. What this ASCII stands for? Anyone? American Standard Code for Information Interchange. So we have looked at this ASCII code. You can Google it. You will get it in the Google. You will get this in the Google. In the first column, we have control characters. Those control characters extend from, they are in the range, the decimal 0 to decimal 31, or in hexadecimal, what is the null, what is the equivalent null character in hexadecimal? 00. That means if you want to send null character, you have to send the code 00. That's what it is. 00 means in hexadecimal. How we actually send it? This 0 4 zeros, this 0 4 zeros. We send 8 zeros. If we send 8 zeros at the receiving end, the receiver understands the received character is null character. Otherwise, in another example, let's say if you send 44, it has some equivalent binary. What is the equivalent binary for 44? 0 here, for this 4 0 1 0 0, for this 4 0 1 0 0. That is the binary equivalent of this 44 in hexadecimal. So if we send 0100 and 0100, that is the 8-bit number, at the receiving end, the receiver interprets that 0100 0100 as D, capital D. Like this ASCII code works, right? And there is another code which is called extended ASCII code. This is the extended ASCII code. It was adopted in IBM computers. Because of its popularity, it is also standardized as a normal ASCII code. Now let's see, this is the extended ASCII code. And extended ASCII code starts from 128 decimal. It ends at 255 decimal. 255 decimal. So totally, how many ASCII characters we have? The normal ASCII and extended ASCII together, we have 0 to 255. Means we have totally 256 ASCII characters. Out of this 256, 128 are normal ASCII characters, and remaining are extended ASCII characters. This is the table that is showing extended ASCII characters. Let's see, and this extended ASCII characters have alphabets, Roman alphabets or Greek alphabets, and some special characters like this, and graphical characters, some shaded characters like this, and mathematical symbols like integration, summation, infinity, ohm, like this. So this is extended ASCII code, and we have written some paragraph here about extended ASCII code. Let's read that out. The extended ASCII contains characters in the following general categories. It has non-English alphabet characters, foreign alphabet characters, not the language of all countries, but selected non-English characters, foreign currency symbols. It is not having our Indian rupee, maybe selected foreign currencies, Greek letters, mathematical symbols. Just now we have seen integration, those things, Greek letters like A, alpha, beta, gamma, those things. Drawing characters, bar graphing characters, shading characters. These are included in extended ASCII code, whereas normal text like uppercase, lowercase, 1, 2, 3, all those things are present in these general purpose characters are widely used, mainly used characters are present in normal ASCII code. So that completes the alphanumeric codes.